Hi everyone. So my name is Boaz. I'm the CEO of Drive, which is an innovation center for mobility here in Tel Aviv. And we're going to talk a little bit about automotive. And the topic that we're going to have is going to be about talking a bit about 5G and V2X. Basically, when we're looking at automotive, the paradigm was that in the beginning we didn't thought about automotive as something that have a cyber risks. Or even if you have a cyber risk, you have to have some kind of hands-on access to the car in order to hack it. But today, with the increasing of connectivity with cellular and also with other methods, the risk is growing. And we're going to talk a little bit here in this panel about the risks and maybe the opportunities that coming with 5G and with V2X solutions. So I'd like the panelists maybe for 1 minute to present themselves and their company.
Hi everyone, my name is Halachmi. I work for Huawei. Huawei is the largest ICT vendor in China, about 180,000 people with a revenue of $93 billion. We have three main business group. In Israel, we are most famous for our consumer, which is the smartphones, but originally we came from the carrier, from the telecom industry, and now we have third division that is focused on enterprise, and under that division we're also working on automotive.
Hello to you all, my name is Ori and I'm the CIO of ECI. ECI works on the telecom industry. We are a 50 years old company, one of the first pioneers of the high-tech industry in Israel, and I'm the CIO of this company for the last a year.
Hello everyone, my name is Andrey Eidelman. I'm the security architect at Gett. I think most of the people from Israel are familiar with Gett, but maybe the people from abroad is not. So Gett is connecting riders, people who are looking for the taxi, with the taxi drivers. We are a marketplace who are connecting them together. That's all.
Okay. Good morning. My name is Laila Ahddar. I'm head of Cybersecurity for the Alliance for Connected Vehicle and Mobility Services. My previous background is I come from cybersecurity, but in pay TV operator, and I continue to Nagravision for developing some control access system for pay TV, and after that I joined the MNU mobile network operator in France, Bouygues Telecom, before joining the automotive company that Alliance.
So we're hearing a lot about 5G, and Nir, maybe we can give us a bit of background about what is it? Is the big buzzwords 5G, how it's connected to automotive, what is the use cases, how it's different from the 4G that you used to know now.
Okay, so by show of hand, who in the audience have heard about 5G? Good crowd. Who knows what 5G is actually different from 4G? It's not. Okay. That's an interesting perspective, but anyway. So let me give you a bit of ours.
5G is not 4G on steroids.
Hopefully not. Can I use this mic? Oops, can you hear me? Okay, perfect. So I'm really not gonna get you into the bits and bytes, but here's a bit of an intro. So 5G is an evolution in mobile standards for mobile communication, but people tend to get confused with the fact that it's all about technology. When 5G was started, the telecom industry looked at which use case do we want to serve. And what 5G really is about is, like people mentioned, it's more than 4G on steroid. It's also a new architecture, new concept, and it's kind of combined a lot of other technologies and trends like cloud, like the softwareization of the telecom network, like mobile edge compute, that comes together to hopefully provide a lot of promises in terms of capabilities. Now, when the industry defined 5G, they wanted to focus on three new requirements, three new capability 5G network or technology needs to provide. One called EMBB, Enhanced Mobile Broadband, or in other words, more capacity. We're speaking about faster than fiber, mobile beyond giga, for a cell site. The second, which to me is the most relevant for this type of industry and vertical, is ultra low latency. And if I want to be a bit more precise, ultra reliable low latency. We're speaking about, and again, the numbers vary a bit, between or something that is lower than 4 milliseconds end to end, not just on the air interface, because a mobile network is combined out of several segments. So between two end terminals where we want to have the capability to provide this ultra low latency service. And just one interesting comment about that, when the industry started, ultra low latency was kind of the holy grail, and people put a very ambitious number of 1 millisecond. And once the discussion with our customers, and many automotive are a target audience for such a discussion, the industry started to shift a bit and first extend the number from 1 to 4 or even 10. And secondly, focus more about dedicated low latency. I think this is a very key point to this industry. The ability to provide ultra low latency for 99.999 part of the time, but still be allowed to have a spike every now and then that exceed that, can be applicable for certain industries, certain use cases like VR/AR, but can be catastrophic for a connected car if a critical infrastructure is relying on this latency. And thirdly, we speak about a massive machine-to-machine communication, the use case of IoT, and that required the ability to support up to 1 million connected device per square kilometer. Now let's focus, because we're here speaking about connectivity, let's focus a bit more about the connected car use case. So firstly, there's a very big transformation, and we're speaking of cars coming from just a car to becoming a connected car. And I think it relates to a lot of the discussion here about cybersecurity. This transformation is the shifting point and the most challenging point of this whole process, because up to now, the cars were some sort of an island. And when they were designed, when they were developed, was like to develop a standalone product. But once the car getting connected and access to it becomes possible from every point in the network, this is where it gets very tricky. And the process of how to redesign, how to get security by design, which was raised by many people, is becoming critical. But this is also a huge opportunity, both for many industries, like the telecom, like the car automakers, to make additional revenue, to make and support new emerging business models. So connectivity is becoming an enabler. And this will, of course, unleash a huge potential to the automotive industry to get into the value chain of everything connected. So if we speak, let's take one simple use case about fleet management. Okay, so today, every work on fleet managers is over the top. But as of tomorrow, in the near future, if everything is connected, the car OEMers can start to provide these services much better because they know the ins and outs. So it's another great opportunity for them to get into the value chain and get hooked to additional sources of revenue. We can speak here a bit more about certain use case. One very interesting that I chose to show here is TOD, teleoperated driving. And now TOD is currently introduced to the industry in two main use cases. One is to support the shift from level 2, level 3 autonomous car to up to level 5. I mean, how can the car handle the edge cases? gets into a situation where the autonomous software simply doesn't know what to do. Then there's a whole concept of teleoperated driving. The car will pull over safely, will call a human operator that sits in a knock, and this human operator will get it out of the hazardous situation, get it into a situation where the autonomous software can get control again, hand it over the control, and move on. The second, now for this use case, you can find today solution in the industry running over 4G network. The main issue is, let's go into the finest details. How fast can they go? Now, maybe for edge cases, they don't need to drive as fast. Therefore, the latency on the 4G network is enough today. But if going forward and we want to add more and more capabilities, then we'll have to provide it much lower latency. But TOD has another use case, which is, for example, dedicated machineries. Look at this big truck. I mean, look at how big the driver cockpit is from the payload of this huge lorry. What if all of this cockpit is just a small box, hardened box? It controls the steering wheel and the engine, and all of this is done remotely by a driver that sits somewhere and drives this car. I mean, and these are the kind of use case that we'll probably see first emerging because the environment is much safer for them. Okay, it's probably working in some sort of a mine, so the whole environment is closed and contained. You don't have a lot of security issues, or safety, sorry, not security, safety issues. And secondly, there's a very clear model and very short way for return of investment. And we are aware of this, and we're also working to support some of these use cases. Last, but one of my favorite capabilities is 5G network have, which is very critical for the automotive industry, is an ability called network slicing. Because when the industry sat together and said, okay, we want to handle this use case and this use case and this use case, they are not, each of them has a unique set of requirements. And sometimes these requirements collide, okay? If I want to provide the highest bandwidth I can, maybe it's collide with my will to provide ultra-deterministic low latency. So I need to somehow be able to optimize using the network in a different way for a different type of services. And from that point, the concept of network slicing emerged. Network slicing is an embedded capability in 5G technology that allows the operator to slice a complete set of resources throughout the network, radio, transport, core, and basically assign it to a specific service, also optimize it accordingly. For our work and cooperation we're doing with some of this, the use case providers, we already start to see the different requirement, not just on the network behavior, but also on which kind of characteristic the network has. For example, if I'm running an automotive critical infrastructure, a V2X, I want it to be super secure. I want it to have a lot of predictability and analytics capabilities. These softwares, these components cost a lot of money. There's no point for the operator to spend these capabilities on a simple mail service that it provides. So network slicing really allowed the operator to optimize the slice it gets. Moreover, it opens up a way for new business model. For example, now an operator like Deutsche Telekom or Verizon or AT&T can sell a network slice to a car manufacturer like Ford or Renault, and giving them the ultimate ways to optimize and to build the network as a basic enabler for the business in the way they see fit. So, and one more comment, when people speak about connectivity to the car, they have one thing in mind. Let's put the bits out there, but inside the car, and I think it was mentioned in the context of a train, but the same applies to car, there will probably be 3 or 4 different types of networks with three or four different types of requirement. There will be a critical infrastructure. There will be some analytics that can be maybe provided in the best effort manner. There will be the infotainment system, which will require a huge amount of data because you'll probably have a 4K video on the back to show your kids the latest clips. But of course, you don't need that type of a network to get a dedicated bandwidth or dedicated resources to provide an ultra-low latency. So don't just think of the car as a one entity with one set of requirements. Think of it as 3 or 4 different types of networks that are all unifying under one API. And I think these type of requirements are what makes 5G a very interesting and very key technology for the automotive industry moving on. With that in mind, I'm coming from a group in Huawei called XLabs. It was founded in 2016. And the whole purpose of this group is to do some technology exploration, innovation, ecosystem building for the different verticals that require 5G. So I encourage everyone that thinks that we can partner together and help build use cases or innovative solutions to come and reach me afterwards. Thank you.
Thank you, Neil. So now after we heard about 5G and all the potential we have in 5G, and we're all aware of the DSRC that already exists today with connectivity, we truly understand that there is a lot of risks also, cybersecurity risks. So maybe you can elaborate for us guys, what do you think about it? Is it more dangerous than the opportunity? And what should we do in order to protect the cars? So, Ori?
I think I will take it. Sorry. We're already faced with a lot of issues with cybersecurity and fraud attacks on our systems because for example, we have currently two main applications, one for a rider, one for a driver. And basically, if the driver app can be located on the in the car itself, it's the same for us. We're trying to create for a driver and some communication channel which only be for communicate with our server without providing him some additional abilities. Don't provide him, for example, to manipulate with the car, only the communication with the server. So we try to authenticate it, the driver, to identify him, to identify the device from where it's come, because one of the basic issues today in the cybersecurity area is the protocol itself. For example, if you take the HTTP or HTTPS, you don't have an ability, and proper ability, built-in mechanism, security by design, how it's called before. We don't have this to detect from where the request is come. We can try to identify it by the IP, but for example, in some regions like Russia, many phone devices have the same IP by the MAC address, but it can be spoofed by another gate if we are talking about the Android, or if we are talking about some other solution which try to identify the device. In the end, they can be spoofed. So we are trying to we've found a solution which allows us to really identify the device and really be sure that the request is come from our application for our devices. But it's very complicated, and we have a very complicated way until we come to there and understand that, yes, we really need to do it.
Yeah, I think also we hear a lot about, critical kind of risks for cybersecurity, but we all know that the real thing that hackers really interested in, most of them it's money. So in those kind of applications, we see more potential for money, frauds. So how do you at Gett deal with that?
Okay. Amazing question. First of all, I will give you an example of one of the fraud which we have a couple of years ago in Russia again. One driver sits at his home. He has two different devices. One of the rider application, a regular user, and the second one with the driver. So he creates an order from one point to the second point, which in a huge amount of money. It's a very big ride very expensive ride. He take it by himself because he is the driver and he is in a very close area, and close the ride after the 12 seconds, if I remember correctly, 12 seconds. Impossible, right? It's not something which looking and be a legitimate ride. So we understand the threats, we understand the flow. We created a machine learning mechanisms which based on these things. We are tracking the drivers, we are trying to understand where they be through all the way to from point 1 to point B to understand if it's looking correct, if the times are correct. We are checking the credit cards before we are starting to dealing with them. We are really trying to understand how the legitimate user should to look, and then when we understand it, we are trying to find and not legitimate users and call them fraudsters, and then we block them, and then we don't charge. For example, if the driver tries to manipulate us when we understand them, so we don't give them the money for this ride. We have a couple of ways how to protect ourselves from these threats. Most of them are basing on the machine learning, and this is, I think, the future. I see a lot of security products which going to this way to learn the behavioral of the user, understand the trends, and then to protect it.
And Ori, how you see ECI see the protection of the car from your perspective?
ECI works mainly on the transport area. As Neil specified before, we have the radio, we have the transport, and we have the core. And ECI works on the transport area, and we are mainly focused on aggregation of the data between the base stations and transport it outside. So the main focus when we are talking about vehicles, we are talking about I can focus about vehicles to the cloud. And when we are talking about a vehicle to the cloud, we are talking about everything from the upgrade of the softwares that will come very soon. I don't know if you know that, but the software of the car will be upgraded, will be patched, in some cases automatically. This will be done through this transport. And more than that, as Neil specified before, the data, the enormous amount of data that will be pushed from the car to the cloud and back forth will be enormous. So it means that we need to have much more bandwidth. It means that we need to have much lower latency, and it means that we need to have much more security, because part of the data that will be transformed from the car to the cloud will be sometimes private and others. It means that we need to build more security around those aggregation layers, and those aggregation layers security can be through NFV that will be in those elements, or through the SDN that will be much higher level that should also support the security elements of the network.
Okay, thank you. So Laila, you're representing the OEMs here. So I don't know if it's to say the customers or not the customers. There is a big debate. Who's in charge of cybersecurity? So maybe your approach. Who's in charge for the cybersecurity, and how is your alliance looking at cybersecurity for car? Well, how do you look on the future services and how it's connected to cybersecurity?
First, the cybersecurity is a little new for OEM, for all OEM and the supplier. It's very important to define that. It's like the railway, it's the same concerns. Regarding the services, that's a very huge challenge for the OEM, because you transform the core business that making a car through provided the services or integrated the services in the ecosystem with a lot of partners. Actually, the main concerns of the OEM is to introduce the security by design, and it's one more challenge for us. And that means secure by design. Also provide the car-centric services. That means how to update some the firmware, because you have to distinguish two things. Car-centrics, a lot of system is doing by I'm sorry. Is done with a lot of code lines of protocols and that. I think the very things important that we have to remove to do, since the protocol is implemented by developers that sometimes is not aware about the security. The protocol used is the good, but the implementation is not the same. So if you want the EOM would like to provide some services. Actually, it's more focused on the car-centrics, more focused on the kind of services you can provide for. Actually, it's very limited as a remote control for lock and unlock your door. And in the next future, yes, you want to provide advanced services and mobility solution. It's a huge challenge for us to develop all services regarding the fact. In first, for cybersecurity team is to help our supplier, to help our company to implement the secure by design. I don't know if I answered to the question, but.
Thank you. So now, if you have any questions from the crowd that want to ask something our panelists.
I can try and take it. I mean, firstly, I don't think it's an ultimate answer. It really depends on a lot of variables, but cellular systems do have a lot of built-in capabilities for lawful interception, so that there are a few things that comes with the technology that are that will increase the security. The fact that all traffic has to go from the car through a base station, through some sort of a core element that can inspect it, that can control it, that can block it if needed, is something that can add a lot of security concern. The whole concept of network slicing will allow automotive slices to deploy many more capabilities. And lastly, let's assume that someone has discovered a bug. Now you need to deploy a patch to fix it. Because the nature of a cellular network is that you have 10,000, 20,000 endpoints, like a base stations or core elements, then patches and security updates can be installed much faster and in a centralized manner. Whether the DSRC are local components within the car manufacturers. So either you have an over-the-air type of an upgrade mechanisms, which again is great, but on the other hand side also expose you to security vulnerabilities, or you need to go car by car, do a recall or whatever. So it's much faster to do that. By the way, one simple fact is that a lot of the cyber attacks that happened, regardless of automotive, are well-known problems that are published on the public domain, have patches and solutions by the vendors, but still there are a lot of legacy systems deployed, which these patches are just not installed. And I think Chris showed a great example of Microsoft Server 2000, which again, probably a lot of people are simply not applying the patches for. So having a local component inside your vehicle and you control, the driver, the customer control the pace when he's going to pull in and do the upgrade is another vulnerability that a centralized system like 5G can somehow ease.
But I think that they will coexist together, eventually. This is what usually is written today, because both of them has the advantages and disadvantages, and it seems like both of them will need to coexist in this way or another with attacking the security capabilities of each and one of them. I think this will eventually what will happen in the future.
Yes.
And we can take it offline, but this is exactly the curve that I was mentioning earlier on about the transformation between a standalone system that is well designed, but it's a closed ecosystem, to a phase where you're opening it all up. I think the telecom industry is undergoing this transformation as we speak with technology called SDN and NFV, which are software version of hardware-based solution. When you want to go digital, when you want to be all connected, then you are now getting into the velocity of IT. IT apply Moore's law, which means that the computation will double itself every year and a half. The velocity there is totally different than the OT and the city. And though, if I'm looking again for trends, then the OT is like lagging 3 to 5 years after the city, which lags another 3 to 4 years after the IT. But once the car will get into this trajectory, we will have to change, we will have to adopt, we will have to build the tools to do this over the air, to do this a continuous development, continuous integration. All of these mechanisms that exist today in IT will have to find their way with the right adjustment for a specific industry. Okay, so again, we're speaking a bit about the future, but definitely this is, if you're looking at the trend, this is where this might, opinion, it will have to go.
And I think also the customers are interested in that. You know, you see Tesla today doing constant updates, and I'm sure that you guys are also thinking about it, how you can do more updates.
Regarding the update, it will be important to know of OEM actually is working to distinguish the safety control between the services controls. It's actually the whole architecture will be designed in the next future. Take care about that to do an aggregation, an isolation between the safety controls and the safety and the services controls. That will be for us very important to distinguish the way to do the update, to do the patch management, and how to maintain to make a new architecture to find the way to how the vehicle will be have your own defense. It's not actually it's not the case because the cybersecurity is just entered and the connected services is very new, but in the design, in the next generation, our concerns. That's why it's very important to know that the OEM actually develop cybersecurity inside and develop a lot of partnership with all actors. That means operators, that means suppliers, to find the best architecture to create an ecosystem in the vehicle that will be very different the vehicle. Why? Because actually the connected vehicle is not viewed as only a way of transportation, but a device that will give to the end user. And for that, we manage also not only the security inside, but the awareness of the end user. That means you have to explain to the end user how to use your vehicle, your connected services, and that to not disturb, to not have the difficulties to facing the safety, because it's the main concerns of the OEM. It's a challenge. We are working on that. We are working a lot of that, how to change the mindset of the end user. First, how to change the mindset of the employees of the OEM automotive is the first, because it's the first challenge for us, because actually the employers know the cybersecurity as only for safety, but it's not only that. That means you have to introduce the fact the vehicle is not only a vehicle but a device. That the good comparison is the mobile device, because you know that, and as you know, the awareness about the mobile device is not. We need again to aware end user. It's the same thing for the vehicle, and to change that we have to discuss. We propose with the dealer, with the concessionaire, to explain how to use the car, how to use your mobile with the cars, how to use the services you're going to provide, how to update your car, because you are going to give some ways to update the cars. You have to install the security. You are not going to give a stick USB to update your navigation maps. You are going to explain when you are going to use that. It's very a challenge, because for that. Regarding the alliance, what we would like is to create a cybersecurity academy for our employees that will be the relay for end user and for concessionaire that will going to sell a new car. It's very important.
Chris, just one idea that comes to mind about the longevity of cars. Okay, so today, because the car is a standalone product, everything happens in the car. And therefore, when you design it, when the new hardware is being released, the capability of the hardware really defines, the longevity. But looking into the future with possibilities of new cellular technologies, possibilities of concept like cloud computing and mobile edge computing, you can start to take a lot of workflow from the car itself, like process it in the cloud and getting it back to the car. And once you break that barrier, you're actually kind of dispatching from the hardware, because then the car basically becomes this very simple and highly reliable terminal, but all of the heavy workloads happen in the cloud, where you just simply don't care about the capability of the processor, because it's been upgraded every 2 years in the life cycle of IT, versus upgrading your car every 2 years to have the latest and greatest processing power. So.
I think we don't have so much time, because we don't want to stand too much before your lunch. I have also one thing to say. You know, we're talking about the future cars. Future cars probably not going to live more than 2 years, 3 years, based on the fact that people are probably not going to buy their car, but consume it as a service. So that could be also an option when you're going to have like cars going to be, use them much more, and then every 2 years they're going to change the car. So they're not really going to have the OEMs or the service provider is going to be in charge of that kind of thinking. But furthermore, thank you very much for the panelists, and thank you very much for your time. Thank you, guys.